Hi students, these are the lesson notes for 4.9, the video notes for triangle congruence criteria. These notes are aligned with 4.9, the last page of your Unit 4 Part 1 packet. Thought that this would be included in the Unit 4 Part 2 packet, but apparently it is not. It is in the Unit 4 Part 1 packet, the very last page, okay? So let's talk about what we see here. This video is going to be a little bit different from some others in that you are going to be toggling between this video and a couple of math mashup videos, which kind of explain things a little bit more in detail and give you more of a visual than I can provide on this notes sheet. But let's just talk about the basics here, what the goal or the objective of this triangle congruence lesson is. As a geometry student, what you're going to be asked to do very often is to prove whether or not two triangles are congruent. You will have to write a proof or several proofs, or you will be approached the question will take several approaches in terms of testing or assessing your ability to determine why and how and whether or not two triangles are congruent. How do you do this? Well, congruence literally means if I have an object, a shape, a figure, and I'm comparing it to another to see whether it's congruent to that object, shape, or figure, essentially what I want to be able to do if they are congruent is to take one figure and lay it over the other so that it lays flat and perfectly over that other object, okay? One is not bigger than the other, one is not longer, one is not shorter, and so on. We want them to, if they're congruent, just like a pair of sneakers, you know, they're going to be the same size, ideally. Hopefully you have the same size feet. You don't have like one size 7 and one size 10, but typically when we're buying a pair of shoes or sneakers, those two are congruent to each other. And another way to look at congruence is if, you know, in this case, if I were to take some tracing paper and if I were to just trace over it, pardon my very greasy hands, put on too much oil this morning. If I were to trace this triangle ABC, right, I have this triangle ABC. Okay, if I take this triangle and I move it and I want it to lay flat over this triangle, is it congruent? Well, it is if it lays perfectly flat and there's nothing sticking out, and it does. So we can literally say that triangle DEF and triangle ABC are congruent because they literally can lay flat over each other, okay? That's what congruence means, okay? So two triangles are congruent when all pairs of corresponding parts are congruent. So for these two to be able to lay flat over each other, what would have had to happen is that angles A and D are the same angle measure, angles C and F are the same angle measure, B and E are the same angle measure, and we can see that given the tick marks, okay? So if you look at angles A and D, they have the same number of arc marks, my bad. Arcs are for angles, ticks are for sides. So don't get that confused like I just did, okay? If you look at angles A and D, they have the same number of arc marks. Angles C and F also have the same number of arc marks. And angles B and E have the same number as well. And then the sides CB and FE both have 1. AB and DE both have 2. And AC and DF both have 3. So in addition to being corresponding sides, they are congruent to each other. And just because of this information, all of this, we know that if we take this triangle, it'll lay flat over this. But you're not always going to be given this information. You're not always going to be given this info, okay? Sometimes you're only going to be given maybe 2 pieces of information, and you'll have to figure it out from there whether or not your triangles are congruent. One thing I do want to add, when you're naming whether triangles are congruent, the order of vertices in a congruent statement matters. So if you look at the way this was named, angle ABC is congruent to angle DEF. Notice the way that they're named is literally how the angles correspond. The vertices A and D, right, represent the angles A and D, and they have the same number of arc marks, so they're congruent. The angles or vertices B and E represent angles B and E, and again, same number of tick marks. C and F represent those angles, and they have the same amount of arc marks. Okay, so it's very important to keep the order of the vertices consistent. And we'll get more into detail on that as we progress with this topic. So what if you're not given all of this information and you're only given some information, okay? Now, if you have, these are the shortcuts, all right? If you're given two triangles and their corresponding sides are all congruent to each other, then you have enough information to prove that these two triangles are congruent. So again, you can prove triangles are congruent using the side congruence postulate. Okay? Side congruence postulate. You can also prove triangles are congruent if they have an angle, corresponding side, and another corresponding angle that are congruent in measure. Again, this is if we're not given all this information, but just some information. Or say we're just given a diagram, and the diagrams look like this, right? We're given these two. We can look at these two diagrams and say, yeah, these are congruent because we have an angle, corresponding side, and another corresponding angle that are congruent to each other. Super important. Please remember. Actually, let's talk about angle, side. Okay, so that AAS stands for, let me just put a little cloud around here. AAS is for angle, side. So we have angle, side, angle. Then we have angle, side. All right. So if you have two corresponding angles that are congruent, another set of corresponding angles that are congruent, and then a side that's congruent, your two triangles are congruent and will lay flat over each other perfectly. But what's the difference here? Notice where your angles are located and your sides are located in the angle, side, angle congruence postulate. Okay? So let's look at this first one. I have an angle and then a side and then an angle. So if you read it this way, right, clockwise, and that's the way we do it, clockwise, if we look at it, the side is in between the two angles. That's super important. So the side is in between the two angles. Think of this is the burger, these are the buns, okay? This is the burger, these are the buns, all right? So in this case as well, you have an angle, side in between, and another angle. Now the difference here between angle, side, and angle, side, angle is that you have an angle, and then a side. So the side is not in between in the angle, side criteria or the angle, side congruence postulate. The side comes after two consecutive angles, consecutive meaning one right after the other, or they're next to each other, and then the side comes after. So with angle, side, angle, the sides that are congruent are between the two congruent angles. In angle, side, the angles come first, the side is after. Okay? Angles come first, side is after. All right? Then, side, angle, side. All right. So side, angle, side is another way to prove triangles are congruent. All right? Again, here, what's special about this, the angle is between the two sides. So we have sides, angle, then side. Okay? So whereas in this case, the side is in between the two angles with side, angle, side, The angle is in between the two sides. Side, angle, side. Side, angle, side. That's the fourth way to prove that triangles are congruent. If this is the case, your triangles will lay over each other flat. Okay? And then the last one is hypotenuse leg. Okay? So RASS, it's not ROS. It is right angle, side, side. So what does that mean? You'll have your right angle and then a side and a side. So your right angles are congruent, and then their sides, the consecutive sides or the two sides afterward. So your right angles are congruent, and then you have a side here and then another side. Then you know for a fact that your triangles are congruent, right? And that's called hypotenuse leg, because of course this right here is your hypotenuse, and then you have a leg that's congruent. Okay, so if hypotenuses are congruent and corresponding legs are congruent, then your triangles are congruent. At this time, this has been a lot of information. You are going to click on the link in the description box. There are two of them. You're going to watch both, because one of them is going to explain this a little bit more in detail. They're not very long videos at all. And the other is going to explain this section a lot better than I can without the visual, because I don't really have a really good visual component here. So again, you're going to stop the video now, but you are going to need to click on the links to the other two YouTube videos, okay? Once there's a part 2 to this video where we're going to go over the try it out questions together, all right? Unless you feel comfortable doing them on your own, fine. If you want to do them first on your own and then come back and see if they were correct, great, okay? Go ahead and click on those links in the description box.